Okay, this video is going to cover two-step equations with decimals. Now, there's a little trick that I have for you that I think you might like. It's called clearing the decimals. This is an option, and it's strictly an option when you're solving these type of problems that makes it a little bit easier to work with. What you want to do is you want to multiply by a factor of 10. By a factor of 10 means 10, 100, 1,000, whatever. And here's a little thing. If you multiply by 10, you look at how many zeros there are. There's 1 0, so the decimal is going to move one place to the right. If you multiply by 100, there are 2 decimals, so the decimal is going to move 2 places to the right. So that's what I mean by a factor of 10. 10, 100, 1,000, depending on how many places you need to move the decimals, because you want to get rid of them. That's the goal. So if you look at this problem, if I moved each decimal one place to the right, I would no longer have decimals. So that means I can multiply every term by 10. When you do that, it doesn't change the equation. You'll still get the same solution because you changed every term. So what I'm going to do is take the first term, 10 times 0.2x, plus the second term times 10, 0.8, is equal to the answer over here times 10. What this becomes then is 2x plus 8 is equal to 24. Now that's a much easier equation to solve. So I'll subtract 8 from both sides, and I get 2x is equal to 16. Then I divide by 2, and x is equal to 8. My check step, I want to use the original equation that was given to me. So I have 0.2 times 8 plus 0.8 is equal to 2.4. 0.2 times 8 is equal to 1.6 plus 0.8 is equal to 2.4. This is 2.4 equals 2.4, and it works. Let's try one a little bit more interesting. So look at this one. I want you to try and do this one on your own, okay? And then play the video and see if you got it. See if it matches up with what I did. All right, first of all, there's something tricky here, right here. I would change that right away and then make the problem a little bit easier. So I have, and then what I want to do is I want to move the decimal 2 places to clear out decimals. So I'm going to multiply by 100. So I have 100 times a negative 0.03x plus 100 times 0.9, and it's plus because, again, I changed that. That was kind of a tricky part of the problem, is equal to 100 times 1.11. So what this becomes then is a negative 3x plus 90. 90, guys, because it moved 2 places to the right, we need to fill in that one spot with a 0, is equal to 111. First thing I'll do then is subtract 90 from both sides. And I get a negative 3x is equal to 21. Divide by negative 3 on both sides. And x is equal to a negative 7. And for my check step, I use the original equation. So I have a negative 0.03 times negative 7 minus negative 0.9. It should be equal to 1.11. Negative 0.03 times a negative 7 would give me a positive 0.21. And then the double negatives become positive. 0.9 should be equal to 1.11. Add those together, and sure enough, it works. What? All right, the next one is really tricky. I want you to try this one. This is really tricky because of that. In the denominator, we have a decimal. So go ahead and try this, though. Okay, for this problem, hopefully you realize that you need to multiply by 10. So I'm going to take the first term, 10 times x over 0.5 plus 10 times 0.6 is equal to 10 times 4. This becomes 10x over 0.5 because this is the same thing as 10 over 1. And then this is plus 6 is equal to 40. Okay? Now, where we go from here, you got to be a little careful because this means 10 divided into halves, or 10 divided by 0.5. If you were to actually do that, 10 divided by here, and I could do this off to the side. This is a little reminder of how to do this type of problem. Remember, you can't divide by a decimal, so we move the decimal over one place, so you do it here as well. And then we have 100 divided by 5, which is 20. So if you took 10 and you divided it into halves, you would have 20 halves. Okay, that's just a little reminder on how to divide decimals in case you forgot. And then what you want to do is you want to subtract 6 from both sides first. And then you would have 20x is equal to 34. Divide both sides by 20. And x is equal to 34 over 20. Now, 34 over 20, you could make this 20 goes into 34 one time. There's 14 left over, 20 in the denominator. Then, I know I'm breaking my own rule here, not having more than one equal in the same line, but I'm running out of space. This can be reduced to 1 7/10. Now, if you did 7 divided by 10, you would get 0.7. Or if you know that 7/10 is 0.7, you could change this to 1.7, which will make it much easier to perform our check. So I'm going to come up here for the check step, and I have 1.7 over 0.5 plus 0.6 should be equal to 4. Wow, that's a doozy, isn't it? All right, I'm going to take first this fraction, 1.7 divided by 0.5. Again, I don't want to divide by a decimal, so I move the decimal over 1, move it over 1. This actually then becomes 17 divided by 5. 5 goes into 17 3 times. And then there is 2 left over. Add a decimal. Bring the decimal down. 5 goes into 20 4 times. So this becomes 3.4 then plus 0.6 is equal to 4. 4 is equal to 4. That was a very difficult check, and it was a difficult problem. But you see how the clearing the decimals can help. That is all. Goodbye.